Congratulations! You've made it to the last section of Chapter 8 called Logarithmic Equations. In a lot of respects, this is just sort of the opposite of what we did in 8.6. And so basically, this is what I want to say to you. If the log of x1 is equal to the log of x2, then it is a fact that x1 has to be equal to x2. So if we can get log of some stuff equal to log of some other stuff, then we can solve for whatever the thing is that we're looking for, and you'll see why here in a second. And just remember that the bases do need to be the same. Okay, before I do that, I do want to review your rules of logarithms again, and I want to do it in a little different way, just in case your brain ever fails you, which maybe yours won't fail you, but if you remember, we learned that the log of a product is equal to the sum of the logs of the factors. So I would suggest to you, if you remember, good old log of 100 equals 2, which you can hit your calc log 100 and see that's equal to 2. One way to make sure you're doing it right is to just use something that you feel really comfortable with and think about, well, what are two things that multiply out to 100? It doesn't really matter what. I'll use, say, 2 times 50. So if I have this right, then when I use my calculator, if I put the log of 2 plus the log of 50, it better be equal to 2. Let me see. So log of 2 plus the log of 50, enter. Sure enough, it's equal to 2. So it's just sort of like a way for you to check these rules of the logarithms in case you're like second guessing yourself. So let me just show you another one, and I'm going to continue to use my favorite log of 100. So we also learned that the log of quotient is equal to, written out this way, I'm just going to call it the numerator, the log of a minus the log of b. And so I'm going to stick with my good old friend 100. And so knowing, if I just keep remembering, okay, log of 100 is equal to 2. So I am just going to pick two things that divide out to be 100, and I don't know, for whatever reason right now 202 seem pretty easy. And so if I want to just check that I'm thinking of this correctly, if I type in log of 100 minus the log of 2, it better be equal to 2. So I'll go ahead and do that. So, I'm sorry, the log of 200. Log of 200 minus the log of 2, and when I hit enter, sure enough, it equals 2. Okay. Last but not least, the other thing that comes in handy, very handy to remember, whether you're a memorizer or an understander, is that we learned that the log of a power is the same as bring the power down times the log of the base. And this really comes in handy solving stuff. So once again, going back to my old friend 100. So the log of, I guess the easiest thing for me to do would be 10 squared, has to be equal to 2 log 10. So knowing that the log of 100 is 2, when I type 2 log 10 into my calc, sure enough, a 2 comes out. So anyway, this is my way of just kind of making you realize, even if you think you kind of forgot something, maybe just playing around on your calc a little will help you. Okay, so just a couple examples here. Once again, we're kind of going the opposite direction. So we're going to try to get the log of something equal to the log of something, so then we can basically set those two somethings equal. So here's an example. Solve for x. Given ln of 12 minus ln of x equals the ln of 30. So, what am I going to do? Well, I think what I'm going to do for starters is I'm going to get my x piece of this thing alone. So I'm going to subtract, I don't mean to write that, I'm going to subtract the ln of 12 from both sides. So now I have the negative ln of x is equal to the ln of 3 minus the ln of 12, and I'm going to, you can think about it as multiplying across by -1 or dividing by -1. I want to get this to be positive, so I have the ln of x is equal to the negative ln of 3 plus the ln of 12. And I'm going to just go ahead and rewrite this to be ln of 12 minus ln of 3, because now I can think about those rules I was just reviewing with you. So if you recall then, the ln of x then would be equal to, when I have ln of 12 minus ln of 3, I can rewrite that as the ln of 12 over 3. And so now you'll notice that I have ln of something is equal to ln of something. So since these are both ln's, then I can set those somethings equal. So then x then has to be equal to 12 over 3. So x then is equal to 4. So we're basically kind of just going the opposite direction. Let's see, what else do I want to say about this one? Well, we could check it on our calc. Basically, the ln of 12 minus the ln of 4 better be equal to the ln of 3. I'll just show you that on your calculator. So if I hit the ln of 12 minus the ln of 4, and hit enter, yucky decimal, it better be equal to the ln of 3 or I've screwed something up here. And sure enough it does. They're equal, so it's correct. Okay, here's another example. Example 2. Solve for x. Log x plus log x plus 5 equals log 6. So ultimately our goal once again is to have the log of some stuff is equal to the log of some stuff. So we need to join the forces of these two logs. So basically we know that the log of a product is equal to the sum of the log of the factors. So we can put these back together again. So that's what I'm going to do, is equal to the log of 6. So if this is a log and that's a log, then it means that these guys must be equal. So I'm going to go ahead and do a little distributing here. So x squared plus 5x then has to be equal to 6. And from our experience with this, hopefully you realize where this is headed. Hard to imagine we're doing log problems and factoring's coming in, but it is. So if I go ahead and factor this, I get x plus 6 times x minus 1 equals 0. And x then would be negative 6 and x would be equal to 1. Now, this is a situation that we actually need to reject this, but not just because we reject any old log, or I'm sorry, any negative, but you need to realize that x, the logarithm, is only defined for x greater than 0. So we need to reject because log not defined for x less than 0. That's one way to say it, or we could say that the domain of log is x bigger than 0. So in this case our answer would be x is equal to 1. Okay, one last problem. Solve for b. Log base b 8 is equal to log base 4 64. So this problem has like a little bit different twist to it. So just to throw it in there, you know, we can't like set 8 equal to 64 or whatever, because we're trying to figure out what the heck the base is in this case. So what needs to happen is you need to have your brain realize that that is a number, okay? So either you know the number because a logarithm is exponent and you know what you need to put above a 4 to get yourself to 64, or you do what I showed you in the last section, just take log 64 and divide it by log 4. So in the end then, what we really have here is, as it turns out, this answer should be 3, because 4 to the third power is 64. So we have the log base b of 8 equals 3. And I think this one maybe is probably easier to solve going back to exponential form. So a logarithm is an exponent. This right here is my base, and that must be equal to 8. So I'm going to go ahead and go back to my last chapter and take the third power of both sides of this guy right here. And this ends up being b is equal to 8 to the third, which remember the top is power, root, third root of 8 is 2, to the first power is 2. And there you have it, logarithmic equations. So your job now is to go to MathXL4School.com and do the quiz for section 8-7.